Electric field from a stationary and moving charges. When measuring the dependence of the electric field strength on time at a certain point in space, the graph shown in the figure was obtained. The electric field is created by two identical point charges, one of which is stationary and located at a distance d from the observation point, and the other moves at a constant speed. Find the values of the charges, the minimum distance from the moving charge to the observation point, and the speed of the moving charge. Solution. For large values of time t, the moving charge is very far from the observation point, and therefore the electric field is created only by the stationary charge q1. The magnitude of the field strength is equal to E0. See the figure. Moreover, from Coulomb's law we have formula 1, from where the absolute value of q1 is calculated by formula 2, can be both positive and negative. The sign from the problem statement cannot be determined. The moving charge q2 is equal to q1 according to the problem statement. Formula 3. It is clear from the graph that at the moment of time t equals 0, the electric field strength at the observation point becomes 0. In addition, the graph is symmetrical with respect to the ordinate axis. In this case, the charges are located symmetrically on different sides of the observation point, and the distance between them is 2d. Formula 4. In order to find the speed of the moving charge v, we find the field strength at the observation point after a short time delta t after the field was equal to 0. For definiteness, we will consider the charges to be negative. During the time delta t, the moving charge has shifted a distance v by delta t, see the second figure, and the field has increased by the value from formula 5. Thus, the magnitude of the field strength at the observation point at small times increases proportionally to time. The ratio delta E by delta t is equal to the angular coefficient of the tangent to the graph drawn at the point corresponding to the moment of time t0. It is clear from the graph that this tangent, coming from the origin, passes through the point with coordinates t0, e0. Therefore, delta E by delta t is equal to E0 by t0. Formula 6. Hence v is equal to d by t0. Formula 7. This was the solution for all three questions of the problem.